Asteroid fields are normally portrayed like this. But in reality, they're more like that. Welcome to Cultured Science, where we discuss science, its impact on the world, and the media we love. I'm Mr. E, the science teacher, your host. So in movies, asteroid fields are one of the most dangerous places for spaceships. So of course, our pilot, Mr. Good Guy TM, has to avoid smashing into asteroids. Has to make lots of big flashy maneuvers to avoid getting plastered on the side of a space rock. The enemies, however, not being good guys and not having plot armor, generally tend to end up dramatically smashing into them. At least it saves on photon, proton, or whatever torpedoes. So, what are asteroids anyway? Well, here in my hand, I have an asteroid that fell to Earth near Nantan, China. Yeah, I know it's small, but size isn't everything. Besides, I'm a science teacher. Do you know how expensive full-size meteorites are? Wow, that's a lot of zeros. But hey, at least you have free local pickup. So as you can see, meteorites are chunks of rock or iron from the beginning of the solar system that tried and just couldn't form a planet. You know, I know you tried, little guy. This makes them about 4.5 billion years old, which is probably the oldest thing I have ever held, ever. Asteroids are primarily found in the asteroid belt, a swath of the solar system between Mars and Jupiter. Although there are two big sets of asteroids that Jupiter, being the big bully that he is, claimed for his own. Fun fact, they're named Trojans after the Trojan War, with the ones before Jupiter taking the names of Greek heroes, while the ones after taking the names of Trojan heroes. So the main problem with asteroids is mass. There are lots of them, and some are indeed quite massive. Like this big gal here, Ceres. I think they got the good side of her. You can even clearly see the Silurian Space Empire ice mining station. Now, while Ceres is the largest asteroid and is large enough to be classified as a dwarf planet of its own, it's only the size of Texas. And while I know Texans might disagree, that's rather small on the astronomical scale. So, if you were to take the mass of every single asteroid in the solar system and smush them down into one object, that object would actually be less than half the mass of our moon. Taking that and spreading it throughout the entire width of the solar system means that there's not much there. It's like that time when you have just that tiny little bit of cream cheese left in the container and you try to spread it over your bagel, but no matter how hard you try, you just can't. It just isn't satisfying. There's not much left. Not satisfying at all. So basically that makes itty bitty asteroid and lots of space in between. The average distance between asteroid is 600,000 miles. To put that in perspective, the diameter of the Earth is about 7,900 miles. So you could fit about 76 Earths in between each random asteroid. So far there have been 9 missions sent through the asteroid belt. I know that's amazing to think that we've only sent 9 probes out to the outer solar system. And NASA's way of getting them through the belt safely is just to point, shoot, and then not even worry about it because they're too far apart. So I'm sorry, C-3PO?
Sir, the possibility of successfully navigating an asteroid field is approximately 3,720 to 1.
You're just wrong. Thank you everyone for watching to the end. This has been my first YouTube video. Even more importantly, if there is a topic that you are burning to know more about, or a movie or video game that you want to see scienced, please let me know in the comments below. Also, if you actually own a video game, aka the game developers, and would like to send me a copy of the game so I can science it, please let me know. Thank you.